Okay, this is another example from Pearson Physics 11 text. It is on page 98, example 2.8. It says the Edmonton Queen paddleboat travels north on the Saskatchewan River at a speed of 5 knots or 9.26 kilometers per hour. If the Queen's ground velocity is 10.1 kilometers per hour, 23 degrees east of north, what is the velocity of our Saskatchewan River? So what we are looking for in this example is we are looking for the V current. If I'm looking for the V current, we are going to have to break down these component parts. And a really interesting thing to know about the diagram here is how it's drawn. It's drawn that the V boat and the V current are essentially the components that lead into the V ground. So everything should be in respect to V ground. And we can tell that because of the matter of which it's drawn, that the tip to tip meets here. So let's take that information and let's run with it. Let's start by finding the component velocities of the V grounds. Even though these guys kind of make up and are part of the distance of it, the V ground still needs to have all of its little component vectors that bring it together. So if I sketch this out and I have V ground, what we need next to bring from here is to understand that the 23 degrees is here, which means that our next lines are actually going to be in the northward direction and then in the eastward direction. This will give us our VGX and our VGY. When we calculate these, you're just going to use your trig. So our VGX is equal to 10.1 multiplied by sine of 23. So plug that into our calculator. Gives us 3.95 kilometers per hour, and that is positive, so it will remain in that eastward direction, which makes sense based off of what we've drawn here. Then our VGY will be 10.1 cos 23, which gives us 9.30 kilometers per hour, which again makes sense. That's in the northward direction. That is positive. What we're going to do after that for V boat is first off acknowledge that it is happening all in the one direction here. This is the V boat. So what that means is that it's only going to have a y component. So our VBX is 0, but your VBY is going to be that total value that we had here, which is 9.26 kilometers per hour. So we know those values. That's great. What we need to go from here is we need to figure out all of its component parts. We're being asked to find the V current. So let me sketch that. That means the values that we're trying to find here is we're finding this value here, and we are finding this value here. This being your VCX and your VCY. This gives us our right angle, so life is all well and good in the world. The thing is, I mentioned this at the top of the question, is that this is in respect to the ground, not in respect to the current. So usually when we've done these questions, it was just a matter of saying, okay, yeah, it's VC, which is going to give us both of these, the VG plus the VB in this case, or your air. But this is in relation to the ground. So that means this is usually supposed to be set up like this. Because we're trying to find VC, we need to rearrange this. So VC is actually equal to your VG minus your VB. And you can kind of see I did a little hop, skip, and a step and move some things around a little bit faster. If that's not comfortable for you, pause the video. Make sure that you understand how those variables moved around. This is all going to be our xward direction to start. So that will give us just our 3.95 kilometers per hour because VBX is equal to 0. Then in our y direction, our VCY, it will end up being our VGY first, VBY, which gives us 9.30 minus 9.26, which gives us 0.4 kilometers per hour, still in the eastward direction. The north direction, because this is in the y direction, and this in the east direction. We can now take those values and find the V current. This gets to stay the same, so it's just going to be the square root of 3.95 squared plus 0.04 squared. Square root that answer, and you should get V current is equal to 3.95 kilometers per hour. Then use our tan inverse, or our tan formula, let's write that out a little bit slower, is our opposite over our adjacent. So theta is equal to the tan inverse of our opposite, because we're finding our angle here. It is your VCY. Where's that other value? So then that is second tan or shift tan, whatever your button happens to be, which gives us 0.580 degrees. This is a little bit more sig figs than we typically want when it comes to degree measures. So we're going to shorten this to 0.5 degrees. If the question explicitly stated that it was to the nearest whole degree, it's just asking for the velocity. So I would leave it at this stage. So then our final statement here is the current velocity, the current's velocity is 3.95 kilometers per hour. Looking at this is going upwards. So this is 0.5 degrees north of east. Hopefully that made a little bit of sense. If you have any questions, please ask. Past that, the assignment should feel a little bit more comfortable for you. There may be one additional example to help you find time. Stick around for that if that one is on there. If not, good luck.